Hello students, myself Rakhi Kumari, Assistant Professor in the Department of Electronics and Communication Engineering, ABS Engineering College, Ghaziabad, affiliated to Dr. APJ Abdul Kalam Technical University, Lucknow. Today in the lecture series of Microwave and Radar Engineering, we are going to start with the radar. Till now, we have covered the various concepts of the microwave engineering. At last, we can say that we are aware with the what is meant by the microwave engineering. In the microwave engineering section, already we have studied about the what is the microwave band, what is the role of waveguide, what is the role of TE, TM and TEM modes which exist with the waveguide, and then we have moved towards the different waveguide uh, components related to microwave, for example, magic T, E-plane T, coupler, etc. And after that we have gone also studies the microwave sources. Now we are going to start with the microwave, we are going to end with the microwave and going to start with the radar. So what is the radar? Every one of you are aware with the term radar. Radar is basically one of the most important component which are associated with our defense mechanism. And what is the radar? In general, we can say what is the radar. So whatever it is, basic functions lie in the defense, and whenever we say radar, it means it is giving the signal and it should also have the capability of receiving the signal, and on the basis of received signal it detects the target. What does it mean? That whenever some signal is transmitted from the radar and it will transmitted in all directions, and whenever it get this signal receives the, or we can say get constant with the target. Of course, whenever any obstacle comes in the path of the any signal, some signal get reflected back, and this signal is again received by the radar for detecting whether the target is present and where it is present. So we can see that radar plays a very important role in the defense, because on the basis of that defense officials are able to detect any unwanted substance, any unwanted particle, any unwanted components in the range where no one is allowed to appear. So now radar is an electromagnetic system for the detection and location of reflecting objects such as aircraft, ship, spacecraft, vehicle, people and the natural environment. What does it mean? That this radar is based on the electromagnetic wave system, and it is used for the detection and the location of the reflecting object, because if this is a target, signal is goes on to this target, and when this signal is reflected, it is taken by the radar for detecting the target. And since this all in the electromagnetic waveform, so we can say that radar is an electromagnetic system. How does it operate? It is operated by radiating energy into space and detecting the echo signal. So they say the same thing. It is a radar, it is radiating the signal, a target comes on its way, and this target reflect the signal, or we can say the echo signal reflected from the object to the target, and it is received by the radar for locating the place of the target. Now the full form, actually radar is a short form, so the complete full form, abbreviated form is the radar, and this complete full form is the radio detection and ranging. So that is why we can say radio, that is why we can say that EM wave or the radio waves are used in this, and that is why it is combined with the microwave, because in the microwave also we talk about the radio and the EM wave. And detection, we used to detect the target and also the range, how much distance it is from the radar from which is receiving the signal and which is providing the signal. so what are the advantage which is associated with the radar? That is operates in the darkness, haze, fog, rain and snow. So, we can see that in the adverse environmental condition radar is able to operate itself. Now comes the basic principle of a radar. With those, so the same thing, it consists of a transmitter section. Transmitter section generates a electromagnetic signal in the form of a short pulse of a sine wave, and it is radiated into space. Of course, EM wave, whenever we talk, it is radiated by the antenna. So, in radar it consists of a transmitter section which consists of an antenna which is used to generate the signal into the space, and that signal is the short pulse of sine wave. The portion of the transmitted energy is intercepted by the target. As we know, this is the target, and already we know that for 100% energy to be intercepted by the target, their impedance should be same, but that is not a particular case. So, some energy is received and intercepted by the target, and some is the re-radiation directed towards the radar, some is directed towards the radar, and again there is an antenna which will receive this re-radiated signal, and or we can say reflected signal, and give it to the receiver section. And what happened then? Then in the receiver section, the signal which is received by the reflector antenna now is processed to detect the presence of the target and determine its location. So, this is a basic principle with which the radar works. So, again I am repeating the for your convenience that transmitted signals transmit a short pulse of sine wave in the form of an electromagnetic wave, and it is from the of course antenna, and it is received by the target. Target, of course, it is not possible that the impedance is matched for both. If the impedance is so, here comes the one of the drawback which is limitation of the radar. If the impedance of the transmitter and the target is matched, in that case we are not able to detect the target with the help of radar. So, what is happening? So, some as per the impedance matching condition, since it is not matched, of course, the 100% radiation should not be intercepted by the target, some will be reflected by. So, in this case also some signals will be reflected by, and reflected by, and radar contains another section also which is our receiver section, and it is also a receiver antenna. So, that reflected signal received by the our reflected signal, and that signal is given to the receiver section for the another processing and for detecting the presence of the target and determining its location. So, this is a diagram depicting the basic principle of radar. So, what is going to have here? This is our system of radar which consists of our transmitter and the receiver section. Here we have taken an antenna. Of course, this antenna is of a duplexer type. I think every one of you are aware with the duplexer type antenna. Duplexer type of antenna means that it will behave as a transmitter and the receiving antenna both, but not at the same time, but at the alternate time. When the signal is transmitting from the transmitter section, in that time it will behave as a transmitting antenna, and when the signal has to be received, it will behave like a receiving antenna. So, that is why a single antenna is used here. Now, this is our target, or of course, we can say this is an unwanted object which has entered any territory. So, what we going to happen? Signal is transmitted from the transmitter section, and the transmitting antenna is transmitting into the free space. This is our free space, and this is a signal, and it interacts with the target. 100% energy is not intercepted by the target, some will be reflected back, which is represented as a echo signal, and it go again received by the receiving antenna and transmitted to the receiver section for the processing, and which will tell us what will be the where is the target and what is the range of the target. So, this is the basic principle of radar. Now comes the radar block diagram. So, till now you are already aware that our radar system consists of a transmitter section and receiver section both. So, this block diagram is divided into a transmission section and the receiver section. So, what is the thing here? Here is the waveform generator, because signal has to be generated so that it can be transmitted, and power amplifier, duplexer, antenna. Here it is first, in this first case it will act as a transmitting antenna, and the same will act as a receiving antenna for the reverse case when signal is reflected from the target and it has to be collected. So, what is going to be here? First low noise RF amplifier, then mixer. What already all of you are aware with the principle of the mixer. What is going to happen here? This is a signal. Of course, this is called as a low noise RF amplifier because the signal which is received after the reflection is of a low power, and here signal from the local oscillator, mixer. Of course, combining with the mixer, it generates the IF signal, or we can say intermediate frequency. And this is the IF amplifier which will amplify, because this power of the intermediate frequency is very low. So, the IF amplifier here for amplifying the signal. Then the second detector will detect the signals and it will change that into the acceptable by the receiver section. Then the video amplifier which will further amplify the signal, and after that there consists a threshold decision. Threshold decision will basically show that if some threshold value is given to it. So, if the signal strength crosses that level, then only it will display here, otherwise it will not. So, this is a basic block diagram of our radar, and you have the questions comes in your subject. So, as to draw the block diagram of the radar, because this subject includes only the basic introduction of the radar. So, you are not required to go into depth into the radar system. So, in this a very common question is asked that draw the block diagram of the radar and explain its different blocks. So, one by one we are going to explain the different blocks of our radar system. So, since we know that our radar is divided into two sections, that is transmitter section and the receiver section. The first one already known to you, that is the waveform generator, power amplifier, pulse modulator and the duplexer. This is a part of our transmitting section. And the receiving section, low noise RF amplifier, mixer, local oscillator, IF amplifier, second detector, video amplifier, threshold decision and the display. So, the first one is our waveform generator. So, the waveform generator generates a radar signal at low power which is to be transmitted into the signal. So, as the name indicate that it will generate a signal which has to be transmitted into this space, and we know that in radar we use the microwave signal. So, the basic microwave oscillators can be used. So, one of the basic oscillator which is generally used is the magnetron. We all aware with the two type of the microwave oscillator. First one is the reflex klystron and the second one is the magnetron. And we know that reflex klystron is limited to the very much limited to our laboratory purpose, and magnetron is practically used in the defense mechanism very much. So, the waveform generator is basically the magnetron. Now, the transmitter, the signal generated by the waveform generator is fed into the transmitter, can be magnetron, travelling wave tube or the transistor amplifier. So, what will the transistor be? You already aware that a magnetron will generate a very low power. That means it has to be amplified. That is why a travelling wave Q or transistor amplifier. A magnetron also works as an amplifier, that it can so transmitter section consists of the amplifier part of the microwave, which you have already studied. In the case of a pulse radar, so basically it is one of the type of a radar. We will deal with this further. Magnetrons are widely used as a transmitter, but whenever there exists a need of high average power, then amplifiers are used. So, what is saying here, that it is one of the type of our radar, that is the pulse radar. So, magnetrons are widely used as a transmitter, but whenever there is a need of high average power, then amplifiers are used. So, proper microwave amplifiers are used. So, you have to keep in mind that the transmitter section basically consists of the amplifying section of the radar. Now, what the third one is the pulse modulator. What is the function of a pulse modulator? Pulse modulator is basically used to build a synchronization between the transmitter section and the waveform generator, because signal, whatever signal is generated from that waveform, it has to be amplified. So, there should be synchronization between the waveform generator and the transmission. The pulse modulator causes the turning on and off of the power amplifier according to the input pulses generated by the waveform generator. So, basically in the transmitter section we have a power amplifiers, or we can say amplifiers. So, the function of a pulse modulator is to on the power amplifier whenever the waveform generator generates a signal, or switch it off when there is no signal generated from the waveform generator. Now, the function of duplexer, basically duplexer is used to form the isolation between the transmitter section and the receiver section, and it allows the use of a single antenna for both transmission and the reception purpose. So, the two basic functions of the duplexer, first is the provide the isolation between the transmitter section and the receiver section, and second, already known to you with respect to antenna, that is with the help of a duplexer we are able to use the single antenna for both transmission and the reception purpose. If we do not use a duplexer here, in that case we have to use two different antenna for the transmitter and the receiver. However, both the sections operate at different power level, therefore, duplexer is used to isolate the two sections. The signal from the transmitter is provided to the antenna through the duplexer, and the duplexer short circuited the input of the receiver section. So, what is happening here? When the transmitter is working, then the duplexer is used to transmitter is provided to the antenna through the duplexer for transmitting the signal. In that case, our receiver section, it has been short circuited by the duplexer. At that time, our receiver section is not working. And in the next case, in the reradiated signal received by the common antenna is fed to the receiver section using the duplexer, and in that case our transmitter section has been short circuited by the transmitter, and in that case we can say that it is used to provide the isolation between the transmitter and the receiver section. Now comes the receiver section. So as just have a look at the receiver section part again. What is carrying here? Low noise RF amplifier, mixer, IF amplifier, local oscillator, second detector, video amplifier, threshold decision and the display. Low. So, low noise RF amplifier. So, what is the role of this? After getting the re-radiated or the reflected signal from the duplexer antenna, the signal is given to the low noise RF amplifier. So, you can see that I am not included the duplexer here in the RF section, but you can include because duplexer consists both the part of the transmitter as well as the receiver. So, low noise RF amplifier, the receiver must be super heterodyne. The unit act as a input stage for the receiver section, because here we can give the signal from the antenna to the receiver section. The RF amplifier generates an RF pulse which is proportional to the echo of the transmitted signal. So, the echo which is received of the transmitted signal is made proportional to the RF pulse with the help of low noise RF amplifier, and it is act as the input stage of the receiver section. Now comes the mixer and the local oscillator. The function of the mixer and the local oscillator is exactly the same which you have already studied in the communication section, but the term where is RF pulse. The RF pulse received from the low noise power is converted into the IF pulse with the help of a mixer, and for converting into the IF pulse, what thing we extra require? First the signal, and second one is the signal incoming signal, and second one is the signal from the local oscillator. So, RF pulse is of course the incoming signal, and now we require the signal from the local oscillator. That is why both are included simultaneously. Usually the RF amplifier act as the input stage of the receiver section, but sometimes the mixer act as a input receiver stage by eliminating the RF amplifier. It may be the some case where this low noise RF amplifier is not included. The signal coming from the antenna is directly fitted into the mixer, but this leads to less sensitivity receiving section due to the high noise figure of the mixer. But this condition has to be avoided because this led to less sensitive receiver section. Now comes the so by getting the signal from the our low noise RF amplifier, that is our incoming signal, and getting the signal from the local oscillator, what we are getting? That we are getting from here our IF signal. Now this signal has to be amplified. The IF pulse generated by the mixer circuit is amplified by the IF amplifier. It acts as a matched filter, and what will it do? If it acts as a matched filter, it increases the SNR of the received signal, and also it enhances the echo detecting capability of the receiver. So, our IF amplifier is used to basically amplify the IF signal which is received by the mixer, which is received from the mixer, and it basically consists of a matched filter which basically increases the SNR. SNR stands for the signal to noise ratio of the received signal, and it enhances the echo detecting capability of the received signal, which is our main function. Now, the second detector or the demodulator. The function of demodulator is same as we have in the communication. The unit is nothing but the crystal diode, consists of a crystal diode that perform the demodulation of a signal by separating the transmitter signal from the carrier. In the demodulator section, in normal communication system also, we basically transmit the separate the modulating signal from the carrier. The same thing is happening here, and basically our modulating signal consists the information. Here that function is performed by the transmitter signal. So, in the demodulator section, we are basically separating the transmitter signal from the carrier, same as we used to done in the communication system. This unit amplifies the received signal to a level that can be displayed on the screen. So, what is the function of a video amplifier? That it amplifies the received signal to a level that it can be displayed on the screen. Now comes the threshold decision. This unit makes the decision about the existence of the target in space. So, basically it has some threshold limit set which is compared with the magnitude of the received signal, and if the magnitude of the received signal is above that, then only we can say that there must be a target. If the our signal which is received is below that, in that case we can say that there should not be any target. If the threshold value is surpassed by the output, then it shows that presence of the target, and otherwise it assumes that only the noise component is present in the space. So, this the purpose of a threshold decision is very important, because from here we can basically decide whether the target is present or not. Now, display unit, as we know already, it shows the output of a receiver section, and it represents the range and the location of the object if by mapping it in a polar coordinates, and PPI is implemented with CRT. So, here in the display section we are actually able to present the range and location of the object, and this is only possible if we amplify the signal with the help of video amplifier, and just signal received surpasses the threshold value, and then the target is and we can see the target is present, then only these values are detected, otherwise it is not possible. The output signal modulates the electron beam of the cathode ray tube in order to permit the electron beam to switch from the center in the outward direction of the tube, and this sweep shows rotation in the synchronization with the pointing of the antenna. So, the modulation and the demodulation is a very important concept, same as our communication system. Now comes the application of the radar. So, there are various applications. The first one is the military. It is a major application of the radar, and it is one of the most important parts of the air defense system. Already we have discussed with the respect of the defense mechanism only. Radar used for the purpose of navigation and surveillance in the military for secure operation. Already we have discussed, because the main example here is the defense mechanism and the aircraft only. Also the radar can be used for the remote sensing. All radars are remote sensor. For important examples are weather observation, planetary observation, short range below ground probing, mapping of sea, ice to route shipping in a efficient manner. So, let us take an example. Also in the sea, we used to send the signal, and if some obstacle or we can say iceberg etc. is on the path, then it will reflect the signal, and this can be detected by the radar, and in that case we are able to detect that there must be existent and any iceberg, and what is the range, what is the location also. So, we can say that it is used for the efficient route of shipping in a efficient manner. Air traffic controlling is a very important factor, because it avoids the accident etc. Because if the aircraft is running and on its path another one is comes, then there is a chances of an accident. So, with the help of radar we can have the we can able to detect whether the radar is on our path or not. So, radar is used to control the air traffic in air routes and airports. High resolution radars are used for analyzing the aircraft and ground vehicular traffic at the air. The next one is the law enforcement and highway safety. The radar speed meter is used by the police for enforcing speed limits. So, basically these are the advanced form of radar, or we can say these are the applications of radar. Aircraft safety and the navigation. The airborne weather avoidance radar outlines regions of participation etc. to allow pilot to avoid hazardous conditions. Low flying military aircraft rely on the terrain avoidance and terrain following radars to avoid colliding with obstacles or high terrain. Ship safety. Radars are used to provide safety measures to the ship in bad visibility conditions by giving alert about the existence of other ships in the route, because other ship will also, if we provide the signal to the radar with the help of radar, if we transmit the signal with the help of radar, it get obstructed by the other ship and it will reflect the signal, and if it reflect the signal, this can be detected by the radar from the first ship, and first ship will be able to find out that there is a ship in our path. In that case, it will act accordingly. Then radar can be used for the space also. Space vehicles use radar for rendezvous and docking and for landing on the moon. Radars found its application in industry for the non-contact measurement of speed and distance, because non-contact measure, because in radar what is the function basically? We used to measure the distance from the radar to the target, and we can apply that for industry also for non-contact measurement. It can be used for oil and gas exploration. Entomologists and ornithologists have applied radar to study the movement of insects and birds. So, we can able to say that there is a wide range of application in the field of radar. Previously we used to have that in the defense only, but here we can see that radar has finding it application in the multiple areas. So, here I am going to end today's lecture, and we will continue with the more aspect of the radar in the next lecture. Thank you.